Welcome back. It's time to clean up that recurse function where we used global variables to pollute the global namespace just to help us understand recursion as we're getting our feet off the ground. But here we're going to show how to take more of a functional programming mindset where we don't have any side effects, we don't have these global variables. Everything that we want to do is included in the function call itself so that every time you call this function with some input, you can guarantee that you'll get the same output. That's what happens when your code's side effect free. So let's take a look now at the code itself and see how we can get rid of this global counter variable. I see here that we have this counter, and if you recall, we are going to have our base case here. We stop the recursion when counter is 2. And every call, we're simply going to increment that global counter by 1 and then call the function again, which is just going to repeat these 2 lines of code essentially, and then check the base case, increment the counter, call the return statement, and the function, so on and so forth. So this is great for sort of an intuitive understanding that this is always available because it's outside of the scope of these recursive calls. But how do we get rid of this? How do we maintain the exact same structure, the same base case, the same idea of incrementing a counter, but get rid of this global variable? Well, it turns out that functions actually have a little spot where we like to insert variables into their local variable environment when they're called. And that is what parameters are all about, as you might have guessed from the title of this video. Parameters as storage means that we're going to use the parameters to store information about our answer, essentially about our base case that we are building towards. So in this case, the counter is what's changing from one call to the next call. So let's start out by actually throwing in a counter parameter. What does this mean? This means 2 things. One, 3 things technically. We don't need this, no more global counter, of course. But it means that when we first call that function here on line 7, we now need to pass in a counter. So instead of instantiating the counter to 0 as a global variable, we simply pass in the value for the call. And when this recurse function's execution context is opened up, this label counter right here will be 0 for that very first frame of the call stack, that very first execution context. And so it would go in here and it would say, well, is 0 equal to 2? No, so we haven't reached the base case. We would increment the counter, and we'll talk a little bit about why this isn't best practice in a second. My main point right here is what's happening here is we noticed that before we were not actually throwing in any inputs because we were relying on some global variable. But now we're using our parameters to store that changing information. And so this is where we would want to go ahead and pass that counter. You have to make sure, there's a common gotcha, make sure that everywhere where you call this function, when you update its parameter list, you want to go ahead and find each call and make sure you update the inputs that you use. All right, so now looking at this, at first glance, I would not be surprised if developers thought that whatever I was passing in here as my first input, I was just directly sending it in on the recursive call. And this would be silly, right? Why would we want to pass in 0 and then 0 and then 0? That doesn't help us approach the base case. And it's clear that on line 3, we're mutating our inputs here, our parameter, because this is expanded actually to, right, counter is assigned counter plus 1. But this idea of mutating parameters is typically not considered best practice because of the reasons I stated earlier, that it doesn't seem clear that this is different from this. So we might want to create a new variable, call it something like new counter, and then pass in new counter as that updated input. Now when I look at this, I just do a quick scan and I'm digging into the code. It's very clear that that input has been changed, it's been modified in some way. And this is the whole concept of recursion, is that we take our input, we change it slightly, ever so slightly, in this case just adding 1 to it, and then in the next call we check our base case, and if we hit the base case, then we're done. If not, we increment 1 more, and then 1 more, and then 1 more, and so on and so forth until we actually hit that base case. And this is the whole concept of recursion, is that we take our input, we change it slightly, ever so slightly, in this case just adding 1 to it, and then in the next call we check our base case, and if it hit the base case, then we're done. If not, we increment 1 more, and then 1 more, and so on and so forth until we actually hit that base case. So this right here, if we run this code, we see that we actually do return that string done, which means that the counter has actually eventually hit the value 2, and the code behaves just like it did before with the global variable, except this version of our code is much better, much more portable. We could take this chunk of code, give it to anyone else on the project, anyone else could call it anywhere in the code base, and it would give them the behavior that they expect without touching anything outside of the function. This is the concept of a pure function, and it's absolutely crucial in functional programming. And it's just, in general, considered best practice. So please do, moving forward, try to avoid using global variables. That was just for educational purposes. Try to follow this model using parameters as storage. Okay, that said, I'm going to clean up one little thing here. If you're familiar with ES6, latest version of one of the latest versions of JavaScript, default parameters, oh my god, I put a 6 because of ES6, we can actually go ahead and take out that 0 on the initial call, because we don't really care, right? This is sort of an implementation, internal detail of this function, is this counter, we don't necessarily need to pass in that information. We can say if nothing is passed in, just make it 0. And since we're always passing something in on all of our future calls, this means that this will only be 0 on the very first call. So that's just a little tip, a little nice way to clean up your function if you wish to do so. So with that said, please do go ahead, tackle. We have the next challenge set up for you. It is the factorial challenge. Try to do it just like this, where you don't influence anything globally and all of your code is contained within the function. Good luck, and I will see you in the solution video.